Alright, in section 6, what we're going to do is we're going to take what we just learned about systems of equations in section 5, and we're going to apply it to word problems, which you're probably going to hate, but it'll be fine. So we're going to learn how to problem solve with these things. We're going to use systems to create models that will help us with word problems. So real quick before we get into it, I'm going to go through these terms for flying. Right, they also work for boating, which will come in handy for problem number 3 that we're going to do, right? But like, just to understand the difference between tail speed, wind speed, ground speed, and then what a headwind and tailwind is. So obviously wind speed is the speed of the wind, right? A tailwind is in your face, so it'll slow you, or a tailwind is at your tail behind you, right? It's going to speed you up. Headwind in your face, it's going to slow you down. Airspeed versus ground speed. Airspeed is just what the speed of the aircraft would be in still air, so what your actual what you would be if there was no wind. And the ground speed, this is a disaster already. Alright, the ground speed is the speed of the aircraft accounting for wind. Okay, so this also is going to come into effect when we deal with current and stuff like that, but the airspeed and ground speed are going to be two different things. So first we're going to start with a couple of easy problems. Okay, so if 8 pens and 7 pencils cost $3.37, 5 pens and 11 pencils cost $3.10, how much does each pen and each pencil cost? Make sure you label what X and Y are going to be, right? Otherwise you'll confuse yourself and mess yourself up, and that's not going to be good. Alright, so X is going to be how much a pen costs, and Y is how much a pencil costs. What you're supposed to be labeling your variables for is always in the question part of the problem. Look at the question part, right? And that's always going to be where your two variables are. So I've got 8x plus 7y equals 337, and 5x plus 11y equals 310. Okay, so I can create my system, my model out of that, and then I can solve. Okay, so I need to do elimination. Makes a heck of a lot more sense than substitution here. So we'll do that. We'll multiply the top by -5, bottom by 8. You could obviously switch that up and go the other way around. But we're going to get -40x minus 35y equals 5 times 3.37 is -16.85. And on the bottom we get 40x plus 88y equals 8 times 310 is 24.8. Probably should have been able to do that in my head. Okay, x's cancel each other out. 88 minus 35 is 53. Couldn't be less of a 5. That's more of a 5, but not a 3. Okay, and 24.8 minus 16.85 is 7.95. Divide there, and you get y equals 0.15. So each pen costs, or pencil costs 15 cents, right? $. Great. Now we get to take that y, plug it back in to solve for x. Alright, I'll just use the bottom equation. So we've got 5x plus 11 times 0.15 is 165 equals 310. So we've got 5x equals 1.45 and x equals 29 cents. So pens cost 29 cents and pencils cost 15 cents. The second one, I must have been in a really weird place when I was creating this last time because I don't know why John Stamos is in here, but he is. Okay, so he's got a marble jar, contains plain marbles, colored marbles, plain marbles, colored marbles. If there are 32 more plain marbles than colored marbles, and there are 180 total, how many colored ones does he have? Okay, so you have to define your plain and your colored. So plain X, colored Y. We're looking for Y, right? That's what we need. Okay, so I know that there's 32 more plain than colored, so Y equals 32 plus X. Other way around. got my variables mixed up. X equals 32 plus y, right? Because there's 32 more plain ones than colored ones. So colored 1 plus 32 equals plain. Okay? Total is 180. X plus y equals 180. Figure out how many y's we have. So substitution is already set up for us, which is really nice. So the 32 plus y is what we're going to plug in for x. We have 32 plus 2y equals 180. Subtract 148, divide, and y equals 74. So if you have 74 plain or colored marbles, that's exciting. All right, let's make sure that this makes sense. So that means you'd have 106 of the plain ones, which is 32 more, which adds up to 180, so we are good to go. Number 3, Bill Nye is paddling his canoe. He goes downstream for 15 miles in 2 hours, returns back upstream, same route, takes 3 times as long, which we know is 6 hours, right? So let's just not worry about that. 3 might confuse you. 6 hours. Right, that's much more helpful. All right, what's the rate of the current? So this one's a little bit more difficult because you're going to have to, defining your variables is a little harder. All right, so we're obviously going to have to use distance equals rate times time. All right, now remember when I said that the current works almost like wind, right? Because going downstream is going to be your rate plus the current's rate, and then going upstream is going to be your rate minus the current, right? Because it's working against you. Right, so your rates are going to be 2 different ones. So x is your rate, and y is going to be the rate of the current. Okay, so I've got x is your rate, y is the rate of the current. Right, so the distance is pretty easy. It's 15. It's how long you're going downstream. Right, the rate downstream is going to be your rate plus the rate of the current downstream, and it takes you 2 hours. Right, the second one, going back upstream, still 15 miles. Now you're going upstream, so it's your rate minus the current times time, which is 6. Okay, so we need to distribute these. And we get 15 equals 2x plus 2y. 15 equals 6x minus 6y. All right, what I'm going to do is I'm just going to multiply the top equation by 3 to set up our elimination, and we'll get 45 equals 6x plus 6y. Now I can add them up. Y's go away. 12x equals 60. X equals 5. Okay, so your rate is 5 miles per hour. And plug it back in to get the rate of the current. So I'm just going to use the top one with it already distributed. So 15 equals 2x, which is 10, plus 2y. 2y equals 5, y equals 2.5 miles per hour. So the rate of the current is 2.5 miles per hour. Now the last problem I'm going to go through is a mixture problem. Okay, so this same kind of thing applies to chemical problems. So if you come across those, which you will, use the same type of deal as you do for this mixture type stuff. Okay, so you've got nuts worth $4 per kilogram and raisins worth $3.25 per kilogram. You're going to mix them together to make 15 kilograms of mixture worth $3.60 per kilogram. How many kilograms of nuts were used? Okay, so I've got nuts is x, raisins y. Okay, so x plus y. Kilograms of nuts plus kilograms of raisins equals 15. And how much they're worth, we've got 4x, right, 4 for the nuts, plus 3.25 for the raisins equals 360 times 15. Now, why did I multiply that 15? Right, so you might have been with me all the way up to that point. You have to remember that when you're creating these models, you have to pay attention to what you're saying, right? And it all has to do with what you're defining your variables as and why you choose the numbers you choose. So remember that x is kilograms of nuts, y is kilograms of raisins, 15 is total kilograms, so that makes perfect sense. That equation makes perfect sense. Kilograms plus kilograms equals total kilograms. Great. Now on the bottom here, I'm saying price per kilogram times kilograms plus price per kilogram times kilograms equals price per kilogram. Right? If you just left it at that, that wouldn't make any sense, because you can't do price per kilograms times kilograms and price per kilograms times kilograms and not do price per kilograms times total kilograms. Okay, so that's why that's so important. Right, so we can work this out now. Elimination works great. Okay, for this problem. All right, let's multiply this whole thing by -4, and at the same time we'll do our 360 times 15. So I've got -4x minus 4y equals -60, and my 360 times 15 is 54. So we're going to use 54 instead. Okay, now I can add these up. 4x's go away. I've got -0.75y equals -6. Divide it. Y equals 8. Okay, so that's the kilograms of raisins, so obviously x plus 8 equals 15, right, when I plug into the original. X plus 8 equals 15, and x equals 7. So 7 kilograms of nuts were used. This is the correct answer. That's it.